Okay, for VRF, it's a very simple calculation. So I have just created one schematic here. Okay, so it's a very basic. See, first we need to understand something that in VRF you have to follow all the steps as it is, whatever we are following. We have to perform the heat load calculation, and obviously we have to perform the calculations on HAP software, equipment selection. Everything will be done. Okay. Now the only difference between the chiller and VRF is that in the chiller system, okay, in the chiller system, we have basically what we have is we are using AHUs. Okay, most of the time we are going with the AHU or CSU units, but in the VRF system, okay, but in the VRF system, we have one option. We can connect multiple equipments, multiple indoor units, like you can connect the AHUs, CSUs. Directly you can connect the split ACs, okay, or cassette AC, window AC, whatever it is, we can directly connect here. This is the advantage, okay. So there are a lot of equipments can be connected, and here the good thing is that multiple indoor units and there is only one outdoor unit, okay. And another important thing here in VRF is that you no need to run the ducting here, just this copper pipe, okay. You can see here, this is the copper pipe which is running here, okay. Now the most important thing here is to get the size of this copper pipe. See, capacity you already calculate. Okay, how to calculate the capacity we already know. We have to perform the same heat load calculation. But getting the pipe sizing, okay, starting from the outdoor unit up to the last unit is little bit challenging here. Means it is not challenging, but you have to perform the calculations. Now, I have one chart here. Okay, this is a Daikin company chart. So with the help of this Daikin company chart, we can actually calculate the pipe sizing. Okay. Now, first we have to understand the conversion here. See, the conversion says that 1 TR in, okay, 1 TR in, sorry, load will become equals to 1.25 HP. Okay. So this is one general conversion. But if you go to the company wise, okay, company wise, the value will change. Okay, somewhere it will be 1.23, somewhere it will be 1.27 or 1.26, whatever it is. But let us assume that this is the conversion. Now let us assume that we have one schematic here whose total load is 64 TR. Okay, and I have converted this 64 TR into HP. So I got 80 HP. Now suppose I am doing the pipe sizing for this 80 HP. Okay. So we will see everything here. So first what we will do means, first let us try to do the pipe sizing first. How to do the pipe sizing? There is a procedure here. So see, there are two things here. So everywhere you will see that there is a ref nut joint which is connected here. So let me just make one ref nut joint here. 1 minute. Just a minute. Suppose this is the ref nut joint. This is the ref nut joint. Okay. This is the ref nut joint. This is the ref nut joint. Ref nut joint. 1 minute. Sorry. Actually, it should be. I'm just trying to make one drawing here. Just a minute. See, usually my ref nut joint will be something like this. Okay. So if I make the ref nut joint here. So I have to just modify this 1 minute. So I'm going to modify this line. Suppose one ref nut joint is connected here. Another ref nut joint is connected here. And it is connected here. Same way, here also I will little bit modify this line. Reference joint is connected here. And here it is. See, we don't require the, see, one reference is required for two equipments. Suppose if you have four equipments, see here if we have three equipments, we require two reference joint. Here we have two equipments, so we require only one reference joints. Here we have three equipments, so we require only two reference joints. So this is the basic concept of, so it is connected here, it is connected here, it is connected here. So ultimately in this particular project, so there are, suppose there are 3, 6, 8, there are totally 8 equipments and we require the 5 reference joints here. Suppose we require the 5 reference joints here. Okay. Now, one reference joint is required here also. So obviously the reference joint is required here also. So I am just going to put one reference joint here. Now, after that, this line is coming here. Now, one reference is required here also. Okay, let us develop this whole line. If one reference is required here.
What is the purpose of reference joint?
I will just give me a minute. I will explain you. Just a minute. If I go here, okay, one reference is connected here and we will go here. Now, the purpose of reference joint is that, okay, the purpose of this reference joint is that you will terminate here the soft copper and hard copper. Okay, so there is a soft copper, there is a hard copper. So in order to terminate the soft copper, you require the reference. See, this reference will have one portion which is connected to the machine and one portion is going and connecting to the another reference here. So this portion which is connected to the machine is the soft copper pipe. Okay. And this is the hard copper pipe. Soft copper pipe means you can bend this copper. Okay. But this copper cannot be bent. So this is what you have to understand here. Okay. So suppose, okay, let us see about this reference is required or not. I think we don't
each
require.
unit, I think each unit we need to do the reference, I think.
No, you don't require in each unit.
Okay.
When you are going to the last unit, so you don't require the reference.
That is last unit fully it is a soft and pipe.
Soft, you can say it is soft. Last one. No, it is not necessary that it is soft here.
Last one.
Yes, but basically,
Okay.
yeah, basically, see, normally what happens when you go, like, for example, it is not necessary that if you provide your refnet, suppose in the last, if you provide the refnet, see, refnet has a property here. See, refnet cannot be left open. So one side you have to terminate, another side you have to take forward here. Suppose if I provide refnet here, so one side I will terminate here, other end will be open. So how I am going to proceed forward? So that is the thing actually.
Okay.
So this is the thing. So here what happens I will tell you. There are two types of pipe sections here. One pipe section is, see, if you check this particular Excel sheet, there are two piping. One piping is between refnet to indoor unit. Means refnet to indoor unit. From refnet to indoor unit, you have one pipe size. Refnet to refnet is you are having another pipe size. See, between refnet to refnet. One is refnet to indoor unit, one is refnet to refnet. Okay, they have given the different ranges. Suppose if your pipe is greater than less than 40 meter and greater than 40 meter. So this is one thing is given here. Okay. Now this is done. Next, first refnet from outdoor unit. Another pipe size is first refnet from outdoor unit. So this is the another. Okay, not an issue. We can come back to that. But how to do the pipe sizing here? Means, see, to do the pipe sizing, we have to start from the last point here. you should not start from the first year. Always start from the last one. Suppose, for example, now I want to start from here. Okay. See, I will first do this pipe size, then I will do this pipe size, then I will do this pipe size, then this pipe size. So all we will follow accordingly. So first pipe size is for 8.5 TR. Now suppose, for example, I have the unit here, 8.5 TR, which is installed. Okay. Now I want to do the pipe sizing. See, in chill water, what we are doing in chill water, we are simply multiplying with 2.4 GPM. So we are getting the GPM value. Then with the help of that equation of continuity Astro chart, we are getting the pipe size. But in VRF, it is not like that. In VRF, we are following some manufacturers, or you can say, see, there are softwares also. Okay, there are software also Daikin will provide. But the thing is, they will not give that software is not free of cost actually. So that software will be provided only if you are a vendor to that particular company like Daikin, Blue Star or Carrier. So they will provide the softwares. Otherwise, they will provide the charts for doing the calculation. Like I have this chart from the Daikin system. Okay. Now, first I have to target for 8.5 TR. So the very first thing what I need to get is I need to get the standard capacity index. Okay. Now, what is the meaning of capacity index means? This capacity index is one value which is set. Okay, from manufacturer to manufacturer, they will set this value. Like for example, in this particular example, they have set the capacity index for the different tonnage starting from 0.6 to 15.9 ton. Suppose they have set the capacity index from 0.6 to 15.9. Now my tonnage is 8.5 TR. Suppose this is the actual load. So let us assume that let us check this 400 one because 8 is the standard size here for this Daikin. So instead of taking the 8, I am taking 12.8. So my capacity index will become 400. So I will just write down here 400. Similarly, we have 11 TR. So first what I will do, I will just write down the capacity index. For 11 TR, again, I'm following the same 400. So this is my 400. Now, if I come back to here, suppose this is the split AC cassette unit. Suppose these are the CSUs. This is one AHU, CSU and cassette unit. I have just given one random example here. Now for 1.5 TR, see, they have given the capacity index of 50 here. So I will write down 50 here. This is the 50. And for 2 TR, the value is 62.5. Suppose this is my 62.5. Now similarly for 4 TR, we have 125. Suppose this is 125. Now 11 TR, we already calculated 400. And for 4 TR, it is 125. Now suppose one AHU is also connected here. Okay, 22 TR AHU is connected. But I cannot find the value here. I cannot find the value here for AHU because the maximum capacity they have given for 15.9. Then what we have to do? In this situation, what we are going to do here means, first let us keep it as it is. First let us do the calculation. Let us see what is the possible we are going to get the pipe size. Okay. Now, suppose for example, say you already know the length here. Suppose I am following this length below 40 meter. Okay. Suppose I am following below 40 meter and piping between the ref net to indoor unit. So first I can write down piping between the indoor unit to ref net. Now first indoor unit is CSU 8.5 TR whose capacity index is 400. So I have to check this table. For 400, my pipe size will become 28.6 and 12.7, suction and liquid. Okay. So one is the suction, one is the liquid. This is given in inches. This is given in mm. So this particular pipe, which is coming here and connecting here, the size of this pipe will become 28.6, 12.7. Okay. Now, the pipe which is connecting to this one, 11 TR. Okay, the soft pipe, copper pipe, which is coming from the ref net and connecting to this 11 TR is again 400 capacity index. So the pipe size will not change here. Your pipe size will become 1 minute. Suppose this is my outdoor unit and this is going. This is how it is going. 1 minute. Wait, this. इधर गया drawing भाई. Where has the drawing gone? No issues. Suppose this is my unit here. So suppose, for example, this is how it is. I have taken two units here. And suppose this is connected to 1, 2, and 3 units. Then it is connected to 1, 2, and 3. And then it is connected to 1 and 2 here. So this is what I have taken here. So this was, I think, 11 TR. This was, I have taken 8.5 TR. Okay, this was 2 TR. This is 1.5 TR. This is 4 TR. And this machine I have taken 4 TR. This is 11 TR. And this is 22 TR AHU. Suppose this is what is we have seen here. Now, we have calculated the capacity index here, 400. This is also 400. See, 8.5 is also 400 we have taken. And for 2 TR, we have taken 62.5. And this 1.5 TR, we have taken 50, I think so. And this 4 TR was, I think, 125. Okay. And this 4 TR is 125. 11 TR is 400 and 22 we have kept it as it is. So here we have taken the pipe size here. So this pipe size is, this pipe size is 28.6, 12.7. And this pipe size is also similar here. Okay, these two pipe sizes are similar. Now, if I need to calculate this pipe size, if I need to find this pipe, so I have to add the 800 here. Okay, I need to add this 800 value. So this will become 800 capacity index. So for 800 capacity index, you have to calculate the pipe. You should not go to this one, refnet to indoor. You should go here, refnet to refnet. Okay. You have to get this pipe size from here. Now, what is my capacity index? 800. So I can go with this one, 34.9, 19.1. So this one will become, this pipe size will become 34.9 and 19.1. You can see that the pipe
From
size
where
is
to
small.
where, sir, this one?
Sorry, here.
From where to where this one? No. That is I got it. From here in the diagram. The size of this from.
See, I am calculating this pipe size, this one. So I have to add the two capacity index, 400 plus 400.
Capacity 400.
It will become 800. So
Okay.
it means that
Was
we
that
got,
horizontal or vertical also?
yeah, vertical also will become same 34.9. Okay, here. Vertical will also become the same size. Now we will follow the same
Up to
exercise
till
here.
here.
Yeah. Now suppose if I want to calculate this 62.5. So I will check here 62.5, 15.9, 9.5. So this pipe size will become 15.9, 9.5. Now for 50, again, about 12.7, 6.4. See, this pipe will become, this pipe size will become 12.7, 6.4.
But this 15.9 and 9.5 from the RefNet outlet to the two-tier inlet.
Yes. Suppose here the RefNet is connected here. Here the RefNet is
From the
connected.
RefNet to 1.5 tier, that is a half an inch and quarter inch.
Yes. Now, if
From
I want to
RefNet
find,
outlet to two-tier, okay.
yes, if I want to find here, I need to check RefNet to RefNet. And you have to count 50 plus 62 here because this pipe is taking for these two units. So 50 plus 62 will give you approximately say 120. So for 120, see, you can take this pipe because here it is telling that less than 150 is 15.9. So this pipe will become 15.9 by 9.5. See 15.9 and 9.5. Now this one, this pipe, this small pipe 125, you have to check here. It will become 15.9, 9.5. So this will also become 15.9, 9.5. Now, if I want to check this particular pipe size, so I have to add all these three. So if I add this 62.5 plus 50 plus 125, suppose it is 240. So I need to check here now. 240 means it is 22.2, 9.5. So obviously you can see that the pipe size is increasing here. 22.5 and 15.9. Now suppose if I want to find this pipe size, what should I do? Any idea? If I want to find this pipe size, what should I do?
We need
to collectively add all the points here. Collectively, we are going to add, suppose
800 plus
237 plus 800. It will be 1037.
Yeah.
Now greater than 920 will always become your 41.3 and 19.1. So this is the maximum size we have achieved here. So 41.3. So this pipe size will become 41.3 and 19.1. Okay. That is two values. Here what they have written. 34.9 is the suction side and 19.1 is the liquid side. So there are two pipes running here. Okay. So one is suction. See, it is a basic direct direct refrigeration is happening here. No. So that is why they have provided here. Now 41.3 and 19.1 is the size we got here. Now again, same exercise we can follow here. Suppose for 125 and 400, we already know what is the pipe size. Now we don't know the pipe which is connecting to 22 TR. So what we have to do here? So suppose if this situation is coming, we are available with the maximum capacity index of 500, okay, which is for 15.9. So either we have to check with the vendor, or otherwise what we have to do, we have to go with a maximum size here. Suppose in this example, I have the maximum size of indoor unit, RefNet to indoor unit is 28.6 and 15.9. I can go with this. Otherwise, what I can do? Otherwise, what I can do? See, otherwise what I can do, I will just simply avoid this AHU here. I will take a separate VRF unit for AHU. I hope you understood my point. I will not add in this because the capacity configuration also I have to check here. So what I am going to do here means, for this 22 TR, I am going to take a separate VRF outdoor unit. So how much capacity is required here? So simply multiply with 1.25. So you require almost 30 HP. Okay, 27.5 means you require the 30 HP here. So one AHU, what we are doing, we are directly taking here. Now, what is the pipe size we are going to give here? Now, that is a big question. What do you think? What should be the pipe size we should give here?
1/8 plus 5/8.
it's better to give this one or to give a next available size 34.9, because this discussion will always lie with the manufacturer here. So manufacturer can suggest us what you have to do here. Otherwise, what manufacturer will tell that don't go like this 22 TR, try to reduce the load here. Means instead of 22 TR, go with 11
You
TR,
can go
11
with the
TR, 2
two 11
HP.
tier 2 machines.
2 HP. Yeah, that is what they will do actually. In real scenario, they will tell that this is not possible. You
And in
have
most of
to
the cases, there is,
divide
I think
11
AH
TR
is
and
not
11.
connected with VRF
No,
machines.
no, it is connected. It is
Okay.
connected. There is
But
a
the
VRF kit. There
design
is a
also will be changed. No? That coil design of the AHUs,
exactly,
everything will be different.
exactly. It will change. Now, if
Okay.
I
And like
connect,
more.
yes, if I connect 11 TR, 11 TR, what I need to do? The same AHU room, I have to make two AHUs. So this is the possible solution, and this is the only solution which manufacturer will give, because we are available with the maximum size of 15.9 TR. Suppose this is every manufacturer will have their own data here. Okay. Now with respect to this, if my design, if I'm talking about this design, now what I need to do, I need to add another values here. Once again, let us try to add 800 plus 125 plus 50 plus 62.5 plus 125 plus 400. So 15,625. So obviously greater than 920 is 15,625 only. Now, one more thing what we are going to do here means, first we are going to also check the capacity, outdoor unit capacity. So first let us check the outdoor unit capacity. Suppose 8.5 plus 11 TR plus 2 TR plus 1.5 plus 4 TR plus 4 TR plus 11 TR. Now my total load is reduced to 42 TR. 42 TR is equivalent to, you have to multiply with 1.25 into 1.25. It is equivalent to 52 HP. See, 52.5 HP means what is the machine you are going to select? Suppose I got 52.5 HP. So 52.5 HP, can we select 54 HP? What do you think? Let us see the configuration here. See, 54 HP is available here. 54 HP is available in this configuration, 18 plus 18 plus 18. But I just want to ask one simple question. Can we select 54 HP here? What do you think? My calculation says 52.5 HP.
No, we need to split it now.
No, we are splitting here.
So we have a two outdoor. No?
There will be three outdoor here. Suppose there will be three outdoor units, because Daikin is providing the configuration here, 18 plus 18 plus 18 HP. But can we select 54 HP, or should we go with a higher value? One higher value. What do you think? Any idea?
No, we can take 52 only because it is a no. We can take with 52 only because it is a VRF machines. So depends upon load only it will work. So we
No,
can go with low side only. No issue.
no, no, no. You cannot select 52 also. You cannot select 54 also. You have to contact the manufacturer and ask for the D-rating chart. There is a D-rating chart.
Okay.
So this D-rating chart, what is the meaning of D-rating chart? Means under worst condition, like suppose if you are living in a city like Mumbai, what is the worst condition in Mumbai? The sea, the water. Water is the worst condition. Moisture is the worst condition. So manufacturer will have their D-rating charts available with them for different cities. So on the basis of that D-rating chart, you have to multiply and divide some values. So what happens when you perform the D-rating chart? Most probably you will retain this 54 HP, or you may get 56 HP, one higher value. So derating condition means because of the moisture, because of the some sea conditions, because of some outside conditions. So what happened? Your machine efficiency will get reduced. Like in electrical, how we are considering the derating factor. So why we are considering the derating factor there? Because of these factors, like the current, the sun, or underground if we are going, or some losses we are considering. So in VRF, this is the most important thing. So whenever you are designing the VRF, whenever you are selecting the VRF system, he is going to ask you, client is going to ask you, have you considered the derating factor or no? So the best option is that if you are doing the VRF project now, or if you are doing the VRF project in future, just connect with the vendor and ask for the derating charts. So take some standard machines like from 12 HP to 50 HP, or if you want, you can select for this entire 10 HP to 20 HP, whatever it is. So every HP unit will have a different derating chart, and different companies will have a different derating chart. Suppose if you are going with Samsung, it will have different, LG will have different, Carrier will have different. So in my experience, LG is the worst machine. Okay. In consideration of the this thing, what you can say, derating, LG is the worst machine. And size wise, suppose if you are talking about this size wise, suppose there are two things here. One is the derating, another thing is the size, means dimension. Dimension wise, Hitachi is the worst machine. Means it will always give you the maximum size. And derating wise, LG is the worst machine. Means the derating calculations you will find more in LG, and the size of the machine you will find more in Hitachi. So the best thing is select the derating, try to contact the LG, get the derating, try to contact the Hitachi, get the derating also, and get the technical specs also. So this is what my experience, because client will ask you two things here. What is the size of the outdoor unit, and which company you have considered, and what is whether you have considered derating or not. I hope you got my point. Is it understandable? So in my experience, I will say that if you are doing the Indian project, so always try with these two, even though if it is not mentioned in your make list, because these two will provide you the worst condition. Hitachi will give you the worst size, LG will give you the worst derating. Worst derating means the maximum size, 54. So the instead of 56, it may give you 58 HP, might be. So always designing on a higher side is always better, you know. Okay. So this is the thing you just keep in mind. Apart from that, you can get from the Blue Star, Daikin, Carrier. Okay. So see, we have to stay in this industry only. So whenever you get any chance, try to get contact with them and try to get the derating factor. So that derating factor will change. It will be valid for 1 year. Okay, every year that derating charts will also change. Might be this chart will also change every year. So whenever you are working on an actual consultant or in an actual company contractor, they will have these charts. You don't need to worry. But try to understand the procedure here. Your procedure will remain the same always. Now, suppose next I need to calculate. Suppose I need to find. See, we have used this sizes, this table, we have used this table, we have used this table. Now we have to use this table. Audio main header pipe size below 90. Now what is the HP? Suppose I am having 56 HP. So for 56 HP, my maximum pipe size is 41.3, 19.1. That means it is talking about this pipe size. Okay. Now, it is very necessary that your this pipe size and this pipe size should match. Suppose here I am getting 34, here I am getting 41. It means that my design is wrong. So both should match, or this pipe size should be always on a higher side. This pipe, what you are selecting from this table, it should be always on a higher side. And this is the configuration. Like suppose I am selecting 54 HP. So I am going with 18 plus 18 plus 18 HP. Or suppose if I am going with 56 HP. So I am going with 18, 18 and 20. So I can directly say that this is my 18 HP. This is my 18 HP. This is my 20 HP. Contact the vendor. You will get the width of the three machines. You will get the length of the three machines. In between two machines, you can take some gap, maybe 500 mm or 600 mm, so that a person can move here. Okay, or at least 400 mm you can take. See how you can select the size of the machine. Suppose this is my entire area of the selection. This is my unit number 1. This is my unit number 2. This is my unit number 3. So, for example, in between two units, at least you should have some distance. Okay. At least a person can move around the unit here so that any maintenance work can be possible. Here also you have to follow the same. And suppose if there is a door here or window or wall here, so you have to make a provision here also, and you have to make a provision here also. Suppose on the back side also if the same situation, so you have to make a provision here also, and here. So the best thing is try to provide at least 400 or 500 mm on all the 3 sides or 4 sides. Otherwise, what you can do means there is an installation guide from every vendor. Every vendor will provide you the installation guide. Okay, I don't remember whether I have the way. What is this? Let us check. There is a separate book actually, installation guide. So you should have that. I will try to get that document. Maybe see, installation guide will tell you the detailing actually. 1 minute. See, this is a technical spec. This is a technical spec here. What you are saying is the technical spec, which is talking about the weight dimensions. We are not bothered about the dimension. We are bothered about the installation here. I hope you are getting my point. Dimensions you will get from the catalog, but I need to check what is the standard gaps or distance we have to provide. So there is a standard document called as installation guide. Let me just check. Installation guide of carrier VRF. It will be available. It should be available actually. Installation and maintenance instructions. Let us check here. I think this is it. See. 1 minute. You don't need to go into the installation here, but you should know the distance between two units. Okay, this is talking about the indoor units only. I think somewhere they have talked about the outdoor unit also. Maybe in the initial pages. See, this is the outdoor unit. See, they have shown you how the unit looks like. Top view, rear view. Okay. But I am not finding the distance here. See, again, this dimension, what is given is this is the dimension of the equipment. But we want the dimension when the configuration of the equipments are connected, how the installation is given. So that document we need to search actually. Otherwise, you need to ask the vendor itself. Okay, like suppose if you are contacting carrier, you have to specifically ask these words. Installation guide. I want the installation guide for the equipments. Otherwise, you can tell them that this is my configuration 54 HP, 60 HP, and so 2020 HP is coming. I want the what you can say some spacing requirements for my units. So they will provide you the guideline. Okay. So it should be available in the internet. So I need to just search it. Somewhere we will find it definitely. At least one, if you find one, that is okay. If you find any one, that is more than enough. Let me check. See here they have written outdoor unit installation. See here they have given parallel connection, the 2 unit or above. Okay, I think here they have given, but still it is not clear. So this is how they have shown the connections. No issues. 1 minute. I think here they have provided one detail here, but again I feel that this detail is not proper here. Parallel connect the front with rear side, because here they have given lot of distance here. 3000 mm means it is 3 meter. It is not the right one actually. You have to get from the vendor itself. So that will be the better. There is a document. There is a specific document in carrier I have seen somewhere. So that will talk about the installation requirements. See, this is also not the installation requirement. What is this? VRF system. That is a different Malaysian they have shown here. Let's see what they will give here. Okay. See this configuration, what you are seeing here, whatever it is, this technical spec is just talking about the equipment here. Okay. So this is also important, but at the same time, what I am trying to tell you that this installation detail is also very important. So I will also try to search somewhere in my documents, and if I find anything, so I will share you. I will share it with you. Okay. I hope you understood the concept here. The concept is understandable or not, because this is a simple calculation we have to do. If you go to the vendor, vendor will do the calculation on the software part. Okay. If we go, it will do. Okay. So I hope you got my point. Any questions you want to ask here? Yeah. Very simple. And okay, refnet sizing is already given here. So we don't need to worry about the refnet, because every company will have their standard refnets. Okay. Every company will have a standard refnet. So you don't need to worry about the refnet here. Okay. We only need to worry about the size of the pipe. Whatever we are selecting, the pipe size, it should not violate the what you can say vendor's requirement. Because basically VRF design is done by the vendor side, from the vendor side. Okay. It's actually the job of the vendor or the manufacturer, but as a designer, we also do the calculations, pipe sizing and all. Okay. So any questions you want to ask here?
Sir, what is the branch kit?
Where is the branch kit? Somewhere.
Branch kit for outdoor units.
See, these are some accessories they will use to connect, like they will be connecting every system to the this one, no, BMS. So
Okay.
like that, and for also AHU also they will have some AHU kits. So might be this is what it will show here. Maybe some layout if you want to check here. See, some layout is also, I will just share it with you, but see, it's a very simple layout actually. We can easily understand. I will share it with you. If you focus on any one outdoor unit, see, suppose if I'm focusing on this outdoor unit, or if I'm focusing on this outdoor unit, so this is the pipe which is going here. You can see refnet pipe connected is shown here. So, okay, let me check some simple one. For ground floor, I think this classroom. The ground floor classroom, what is the ground floor classroom? Where is the ground floor classroom?
అవును ఇక్కడ చపాతి తిని మొత్తం కదా
Just a minute. Where is
అంటే
the
ತತ್ತಿನ
ground?
ಕೆಂಪು ಹಂಗೈತದ
I think this is the ground floor. Just mute it, please. I think this is the ground floor here. See here, from here you can see the refnet joints, refnet pipes are coming here. So now just follow this one. Suppose this one is connected to one unit here. So it is coming here. One refnet is connected here, and here you can see it is terminated. Again, one refnet is connected here. It is terminated to one cassette unit, and it is terminated to another. So you can see that for two cassette unit, they have used one refnet joint here. So one refnet is connecting here, one refnet is connecting here. So this connecting pipe is the soft copper pipe, and this is the hard copper pipe. Then again, this refnet is going forward here. One refnet is connected, it is going on the top side, and here it is coming. Again, here you can see they are connecting how many units? See, so many units are connected here. Suppose two units are connected here, three units. So one refnet is coming here, and it is directly connecting here. And one refnet is going, again it is connecting to one refnet, connecting here and connecting here. So for three refnet, they have used two, for three unit, they have used two refnets. Again, you can see one refnet is taking forward here. So likewise, you can see they have developed the entire drawing here. So just remember the basic concept that whenever you are connecting, see here there are two cassette units, so one ref net is required. Here they have two cassette units, so they require one ref net. Similarly, here they have two cassette units, so they require one ref net here. So if you follow this drawing here, you will understand more in a more beautiful way. Similarly, this particular is starting from here and it is connecting up to this, and it is also going and connecting to this 4 units also. See all these units. So I think whatever the units you are seeing here, it is connected with this one particular ref net here. So these 2 units, these 5 units, and these units are connected. And this brown color pipe is the drain pipe. This brown color pipe is the drain pipe which they have installed. They have just dropped here in the toilet here. And there is one more here. You can see this is the fresh air actually. So they are providing the fresh air also. Okay, sorry, not fresh air. This is the exhaust for the toilet. Fresh air is this green one. See, this green is the fresh air which is provided to each and every equipment. So for every equipment, they have provided the fresh air also. So if you follow this, see one ref net is going here. The two pipes are going here. And where it is connecting, let us see. See, these two pipes are going and see it is connecting here. So these units, they are connecting 4 units. See, not 4 units, this 6 units and here 2 units. So likewise, you have to plan actually. How the routing you are doing, that has to be done. Planning has to be done. Then again, you see, one is connecting to the AHU here. One is directly connecting to the AHU and another two pipes are going down here. If you see here, there is a drop down here. So might be this is the first floor and this is my ground floor. So from where it is dropping down. Just now we have seen that it is dropping here. So where it is dropping. See here they have just shown that two ref nets are dropping here. If I check here. No, I think this is dropping to the basement floor. So if you see here, I have a basement floor also here. So that is the ground floor. What we have seen is the ground floor. Now it is going to the basement floor. Okay. So check, see here. It should drop somewhere from here only. Okay, here you see. Here we have dropped here. Okay, so that point is coming here. See here they have dropped here. So two pipes they have dropped here. And here how many pipes they have dropped here? See, there are two sections they have dropped here. So those two has come here. One is covering this left area, one is covering this right area. See, one is connecting to your AHU again. So all this area is provided by the AHU and one is connecting to your all cassette units. So this is how they have given. And this particular floor is dedicated for operation theaters. So I think here they have not provided the VRF system. So directly they have taken the AHU here. See, if you see here, they have used the AHUs for the operation theaters. So this is a perfect plan here. So this particular floor is not having any VRF. But when you check this ground floor and basement floor, the VRF is given here. Yeah, here there is no VRF actually. No, here there is VRF, sorry. There is one pipe is coming here. Okay, this VRF is connected to your CSUs here. You can see there are VRF system here. Sorry, there are two pipe systems are coming here. So one is connected here. One is connected to all the CSUs. So you can see that one pipe is connecting to all three CSUs, probably 4 CSUs. See, there is one more CSU here. And one pipe is dedicatedly connected to only this 2TR. So we have a VRF in the first floor also, but it is for the corridor protection. Means for the corridor areas or the general areas. And VRF for the ground floor is also there and VRF for the basement is also there here. So all the outdoor units are mentioned here. So these are the total number of outdoor units, which see these are the outdoor units they have mentioned here. Okay. So I will suggest you that just go through these drawings. Okay. And anyhow, it's a simple calculation. Calculation is very simple. The most important thing is how the routing is done here. So if you follow these drawings one by one, if you follow, you will understand more clearly, because this is the complete project here. What I am going to share you this one. This is the complete project from basement to ground floor to terrace. And I will try to find the BOQ also. And anyhow, tomorrow also we will sit. Okay. But at a different time. That time I will explain you. Okay. The BOQ is also there with me for this project. I just need to search actually where it is. I am forgetting. So we will discuss that, and certain more things we will see, if possible, for staircase pressurization or something we will see in tomorrow's session. Okay. So any questions?
Sir, and what is the difference between top discharge and side discharge in VRF machine?
See, that is the top discharge means the machine like your pipes are connected on from the top side, and the side discharge means it is connected from the side. So that is only the difference.
Pipes, sir.
Means your copper pipes.
Okay.
Actually, there are other points are also there. So it's let me check.
Means any capacity means depend upon capacity. We need to go with top
No, no,
discharge
no,
and
no.
side
It
discharge.
is
Anything is there like that?
it is there actually. Like every company will have a different scenarios actually. I will try to search something related to that, because this is
Okay.
very important actually. So I just
Okay.
need to check some catalogs, and I can make one comparison. I will try to
Okay.
make one comparison sheet,
Yeah, we
like
will
which
get more.
unit. Yes, yes, yes. So I will do some research there, because that is important in VRF. Calculation is not important here, because already
Yeah.
we are doing, and the pipe sizing is also simple. But that comparison I
Cost
will
also depend upon that. That also cost will differ. The top
exactly,
discharge will be costly and side discharge is that is
exactly.
I think compared to that is less.
Apart from cost, the size will also differ, no?
Hmm.
The dimensions will also differ. So I will try
Yeah.
to connect the, I will make one comparison sheet, and I
Okay.
think I have that comparison sheet. If I don't have, I will try to make. So I will try to share it with you, so that
Okay.
you will have a clear understanding. So, okay then.
Sir, for this VRF system, the grill size, how we will select grill? I mean, down throw, side throw.
Okay, yeah, we will cover that tomorrow. No issues. That it's a very simple
Okay.
beta software is there. I think that I missed
Yeah,
out. So
based on the LPS, how? Yeah.
LPS based on, yeah, I will show you that. Very simple
Yes.
calculation. We will cover that tomorrow.
Three slotted, four slotted. Yes. Yes.
Yes, yes, yes.
Okay.
Exactly. So, okay then. So let's stop here. Thank you. I will stop.